All right, let's get talking about these thermal energy transfers. Okay, so a thermal energy transfer is heat moving from a warmer object to a cooler object. It doesn't go the other way around. Okay, the heat moves from something that's warm into something that's cold. So here we've got a picture of a pot with some water in it. It says soup. I'm sorry, it's not water, it's soup. So soup is heated in the pan by convection. The hot soup rises, the cool soup falls to take the hot soup's place. Kind of makes sense, right? So here we've got those circular convection currents happening. The fire is down here below. It heats the soup closest to it. Those particles spread out. Well, when they spread out, they get less dense, and less dense things float, right? Well, the more dense things, the colder stuff, it's going to sink back down. Well, what does it do whenever it sinks back down and gets closer to that flame? Why, it's going to warm up again, right? And those particles are going to spread out and it's going to get less dense. So it's going to start floating too. Well, while this stuff was down here heating up, what happened to the stuff on top? It was already warm, right? Well, the further away from the flame it gets, it cools off a little bit. So if it's cooler, the particles get back closer together and it's going to sink back down because it's more dense. And something that's more dense sinks. Well, this stuff here was heating up the whole time, so it starts floating again. And now all of a sudden, we've got this circular current happening, and the hot stuff's rising, and the cooler stuff's falling, and it's just a convection current masterpiece. Super cool, right? Okay, next over here it says a pan handle is an insulator and doesn't conduct heat very well. It's touching the pan right here though, so if you pick up a pan by the handle, it might not feel just cold, it might feel warm or even a little bit more than warm. And that happens because of conduction. There's that direct contact from the handle touching the pan. Kind of cool, right? Okay, and then heat energy from the stove is transferred to the pan by conduction. So we see under here, we see the flame is actually touching the pan right there. Okay, so if we got something touching something else, we've got conduction, because conduction is all about direct contact. Pretty cool, huh? I want to talk about this pan a little bit more just because I think this is fun. So if this pan is on, we're going to have some heat moving up from the pan, right? And if I had, say, my hand and I held it up here above the pan, now I'm not touching anything, but I put my hand right up there above the pan, am I going to be able to feel heat right there? Even if I'm not touching it? I sure will be able to feel heat, and I'll be able to feel that heat because of radiation. It doesn't have to have direct contact, and it's not a circular convection current happening above the pan, but I can feel that heat all the same, and I feel it because of radiation. So here we have the question, how is heat transferred? Well, we kind of talked about them already, but let's talk about them again. We got three ways that heat can move. The first way that heat can move is conduction. Conduction's the first one that we're going to talk about. Do you remember? Conduction, is that the one where direct contact? Is it the one where you don't have to touch it but you still feel the heat? Or is it the convection currents of hot stuff rising and cool stuff falling? That is conduction. It would be direct contact. So we can see right here, we've got an example of conduction. The heat is moving up this fire poker, and you see they've got to have this glove on right here so that their little hand doesn't get burnt touching this hot fire poker. Okay, so that's a good example of conduction. We've got some direct contact right there. The heat is moving with direct contact. Now next we've got convection, and we see convection right here, the hot air swirling up. It would be cooler if it showed you the hot air falling here. Okay, so if the cold air falling. Well, I just messed that all up. So if we've got cold air from up here, it's going to fall because it's more dense, and then this hot air right in front of the fire is going to be going up. I don't think a fire is a great example of convection because it's really hard to see those circular currents. So we're going to move on. The next one we're going to talk about is radiation. Now, a fire is a great example of radiation. So you see how these flames are moving outwards towards these hands over here? I bet those hands can feel that heat because I've been around a campfire before, and I don't have to touch the fire to feel the heat, and I don't have to have my hands right over top of it where they've got their convection stuff happening. I just got to be close to it, and the heat radiates off the fire into my hands. Okay, here we go. We've got some conduction. So heat is transferred from one substance to another through direct contact. So one of my favorite examples of this is cooking stuff. So when you cook something, especially in a frying pan like this, you can see the flames are under the pan. They're not necessarily touching it right now in this picture, but the food is directly touching the pan, and we can see that right in here. I don't know if you can see my little line right there or not. It's not very straight, but that food is directly touching that pan, and the heat is being transferred from the pan into the food, cooking the food. Boom, we have contact, so we have conduction. Okay? All right, so have you ever touched a metal spoon sitting in a pan of boiling water only to be surprised at how hot it is? I've actually done that and burnt my little fingers doing that, because even though you're not touching the water itself, the metal's a good conductor about heat and electricity, and it made that spoon super, super hot. That's why it's much better to use a wooden spoon. So down here it says, think back to what you know about metals, nonmetals, and metalloids. What conducts heat better, metal or non-metal? Why? Well, we just kind of talked about it. Metal is going to conduct heat a whole lot better because it's a conductor. And wood is a non-metal, so that's not going to conduct heat very well. Better option for cooking will be a wooden or plastic spoon rather than a metal one, so you don't burn your hands. Okay, here we've got another example of conduction. A piece of cheese melts as heat is transferred from the meat to the cheese. Direct contact. We can see it right in here. That cheese is sitting on that cheeseburger, and it's melting away because it's directly touching that hot cheeseburger. That's a good example of conduction. Okay, here we have convection. Y'all already know this is my favorite type of heat transfer just because I love those circular currents and the density and all the cool stuff that happens right there. So convection is the transfer of heat through currents caused by the warming and cooling of liquids or gases. Convection currents, there's a good picture of them. And convection moves in a circular pattern. So you can see over here, okay, we're going to talk this out because I think it's awesome. Okay, we got our flame down here at the bottom, okay? It's heating up the water. We'll say there's water in there, okay? At the bottom here, all right? Well, when we heat that water up at the bottom, what happens as liquid or air gets hotter? Well, then particles spread out and they start moving faster. Well, if particles are spread out, do we have things that are more or less dense? We're less dense, right? And a less dense, whenever we did density, the least dense it is, it's going to float. If it was more dense, it would sink. So that's what happens with these convection currents. So down here at the bottom, we spread apart and get less dense. Well, then they're going to start floating, right? So they go up. Well, while the stuff at the bottom of the pan down here is heating up, the stuff up here at the top is still kind of cold because it hasn't been heated yet. Well, what happens when this hot stuff floats up to the top? Well, this cold stuff has to go down to the bottom, right? It's got to get out of the way. Well, when it gets down to the bottom, what's going to happen to it? It's going to get warm, right? So once it gets warm, the particles are going to spread out, they're going to start moving faster, and it's going to float again, right? Well, that is how we get this circular movement. It just keeps going and going and going. The stuff on the bottom gets hot, starts floating, the stuff on the top cools off a little bit and sinks, and there it is. There's your circular current. Here we've got some examples of convection. Have you ever noticed that the air near the ceiling is warmer than the air near the floor? Or the water in the pool is cooler at the deep end? Well, air movement in a home, pot, heating water, lava lamp, all of those things are really good examples of convection, and what's happening there is the cool stuff is moving up and the warm stuff, I'm sorry, opposite way. The warm stuff is moving up and the cool things are going down. That's where we get those circular patterns. I'll go ahead and draw it right here. We got a heater, it goes up, cools off when it gets up to the top, and then it starts coming back down. Well, it's going to move back over here to the heater. It's going to get warm, going to come up, start cooling off. You see what's happening here, right? Just that vicious circle, that super cool convection circular current. I love this example right here of convection because we're going to learn more about this in our next unit, which is going to be plate tectonics. It's one of my favorites ever. But underneath the ground, we have magma, and it moves within the earth in a convection current, just like boiling water or air in a hot air balloon. All these things we've talked about for convection. The same thing is happening inside the earth. The closer the magma gets to the center, the hotter it's going to get. Well, the magma gets up towards the top up here and it's going to cool back off again. But once it cools, it sinks back down, only to get warm again by the center of the earth. Just, I mean, convection currents all over under the ground. Super cool. Here we have radiation. Radiation is the transfer of heat through electromagnetic waves. Radiation does not require matter to transfer thermal energy. Sunlight is a perfect example of radiation. So in order for us to get a sunburn, do we have to go out into space all the way to the sun and touch it? No, we do not, do we? So the sun rays come through the sky, through our atmosphere, touch our skin, and we get burnt from it. Now, does it have to be hot outside for us to get burnt? Well, no, we do not have to be. It does not have to be cold. So I grew up in Michigan, and it is super duper cold in Michigan. It's not hot, okay? All the time. Sometimes in the summer it is. But the worst sunburn I had when I lived up there was in the winter, and there was a ton of snow on the ground. So the sunlight came from the sky, hit me, hit the snow, and then it reflected off the snow and touched my skin still. Well, that was a really bad sunburn. So it does not have to be cold for us to get a sunburn because it's radiation. It's just the transfer of that thermal energy. So kind of crazy, right? Okay, so we talked about the sun. Well, let's talk about some other sources that we might get radiation from. This says, have you ever sat too close to a campfire while cooking marshmallows? Well, you're enjoying the warmth only to notice that your skin got really, really warm. Well, you didn't have to touch the fire for that to happen, did you? Well, no, you just being close to it, you can feel the heat from the flames of that fire. That is radiation. Here we've got a couple other examples of radiation. We've got a fire, we've got heat lamps that you might see down in the cafeteria, and we've got the sun shining on Earth. All three of these are really good examples of radiation.